to solve a polynomial inequality. So what we did in 4.2 was solving a linear inequality, right? So linear, we were doing linear, and then we did some shapes, right? So just for fun, because that was kind of good understanding what the graph of it was. We did a lot of linear and then a few extra shapes. The polynomial inequality. So what we're doing is we know it's a polynomial, so it's going to be one of these guys, right? No bottom, right? No rational, no negatives in the exponent, no fractions, nothing else funny, just polynomial. So we've got the polynomial, but it's going to be an inequality, which means instead of equal 0, we're going to have greater than or less than 0, stuff like that, or equal to that, all that. So to solve a polynomial inequality, you must first determine the roots. So same thing. Okay, so first determine the roots, which is the x-intercepts, zeros, etc., etc. So this is the same thing as x-intercepts or zeros. Right, it's the same idea. So exact same thing as solving a polynomial equation. Then you look at the sign of the polynomial in each interval to find the intervals that satisfy the inequality. So that is a little bit too many words. Okay, what we're going to do is we're going to look at the graph. So my strategy, so this is the theory behind it. Here's my strategy. I'm going to factor, of course. I'm going to factor. I'm going to find the roots, x-intercept 0, same thing. Use a number line or graph or factor table. We're going to pretty much concentrate on the graphing part because that's what we've been doing through chapter 3 and the beginning of chapter 4. We've been graphing. Okay, so we're going to graph it. There's also the number line and factor table, which is this, where they said look at the sign of the polynomial, which means we're just looking to see if the polynomial was above or below the 0 line, right? So we're looking at that. I'm going to explain that in a bit, right? So at the end of the example, mostly what you guys like is you guys like to graph because we just spent all this time graphing, so that's fine. I'm not going to make you do one strategy over another, so your choice. I'll show you the number line, which is basically the factor table, but shorter. So I'll show you this. If you want to, you can do that. Most students are they graph it just because we've just spent all this time graphing it. Okay, so, but I'll show you that as a possibility. That's what this is talking about, the sign of it, and I'll show you what that means in a minute at the end of this first example. And then that determines the intervals where it's positive or negative, so where it's above or below 0. So what we're going to do is we're going to set it equal to 0, and we're going to see when the graph is above or below the 0. So when is the polynomial above 0? So just like what we were practicing here, right? So that's why I want to practice this. So when is the graph above or below each other? Right? But now my line, instead of being at 1 or 0 or another function, it's going to be always 0. So it's actually a little bit easier. The harder part is, look, I need you to factor. So all the stuff from chapter 3, I need you to be able to factor it, and then we got to solve it. Okay? Here's another method. I would not recommend it. I put it into its own box on the side because I don't want to do it. So what you could do is you could graph each side of the inequality. So in 4.2, where I was showing you the 3 lines, the 2 lines like this, you could graph them each individually. Like, that's too much work, right? So I'm showing you the easiest way, which is graphing it like a polynomial and going above and below 0. This method means that you'd have to do an intersection. Say if I had one polynomial intersecting another polynomial, then you'd have to find all the, it's so much more work. So I would not recommend that unless you're a computer. Other than that, no, right? So that's not, so I put it in a separate box. It is a method, not a useful method for us. So manually, then we're doing it. The easiest way is to put everything onto one side, have it greater than or equal to 0, graph it, and then I'll show you how to answer it. Okay, so this is the easiest method. We want it to be 0 and compare it to 0. Again, there are other methods. This is the easiest one, and it'll work for the whole chapter. Okay. The reason why there's other methods is that, again, when we get to harder functions, not in this chapter at all, but if we got to harder functions, we wouldn't be able to use this method because we can't picture the graph. So then we would have to go to a factor table, number line, etc. Okay, but for the polynomial inequalities, we can do it this way for the whole chapter 4. Okay, so we're going to take the polynomial, put it to one side. It should be greater than or equal to 0, or equal, right? Solve using algebra, and then solve using a graph. We're going to do the graph method, and I'll show you the number line at the end. Okay, so here, first step, factor. So first step is factor. Step 1, factor. Okay, you've been seeing us say that since forever. Common factor? Nope, I don't see a common factor. Okay, then let's go to factor theorem. Yay. So the first one I tried was 1, and it actually worked. Yay. So you put 1 in, it was 1 plus 3, and it actually works. So lucky. So therefore my factor is, oh, sorry, I usually did x minus 1 is a factor. Right, there you go. X minus 1 is a beautiful factor. Okay, and then now let's put this into our synthetic or polynomial, up to you. I'm going to do this. I'll put 1 on the outside, and then you've got your 2, 3, negative 17, and 12. And we're going to grab. 2 goes down. 1 times 2 is 2. 2 plus 3 is 5. 1 times that, it'll be 5. Negative 12, negative 12. 0 is my remainder. Yay. And then from here, I know it's 2x squared, 5x minus 12. And then can I factor that more? Yes, I can. Oops, sorry. Okay, so any method that you factor, I do the 2x and x, and I was 4 and a 3, so 8 and a 3, so if it's positive 8 and a minus 3, so 2x minus 3, and x plus 4. Okay, then I do my therefore, right, and make sure you do the little conclusion, so this will be x minus 1, that's my first factor, 2x minus 3, x plus 4, I want that greater than 0. You don't have to put the therefore, just I put it there to remind you. I'm putting it all together. Okay, so again, we're looking for this. It has to be greater than or equal to 0. That's my goal. And we're going to graph it. I'm just going to graph it and look where the graph is above or below the x-axis, right, the 0 line. So let's graph it right here. Up. My points are going to be at 1, and that's 3 over 2, so that'll be over here 1. This will be 3 over 2, and this is negative 4. Okay? Again, the spacing doesn't matter. All we need is the shape. Honestly, if you just have the exact same spacing, it doesn't matter. Right? We're not doing this accurately. Do I need the y-intercept? No. Don't waste your time. You can do it, it's not wrong, but you're wasting your time. I just need to know when is the graph above or below the x-axis. I don't need the y-intercept. If you want to do it for a check, you can, but I don't want you to run out of time, right? Are these all order 1? 1, 2, 3, 1, 1, 1. It's power of 3, so it should be okay. So I know in my head, I go, okay. I know that this is degree, go back to the beginning, 3, and it's a positive leading coefficient. Okay, so in my brain, so I know it's going to be like this. So it's starting down here, order 1 for all of them, and I'm just going to graph it really badly. It doesn't matter. Okay, all I need is where is it above or below the x-axis. You can do the y-intercept if you're like, okay, I want to check to see if my graph is right, so you could check it. It's not necessary for what we're doing. And if you end up running out of time and you're like, oh, it takes me so long, then just assume that hopefully your graph is right then. Okay, so you kind of got to weigh doing too many calculations and I can't finish the question versus, oh, will it help me or not? Okay, so weigh the options there. I'm pretty sure I didn't do anything wrong. Okay, if you quickly do it, this one's fast because it's an expanded form. It should be at 12. That matches. We're good. Okay, so it's up there, 12, good enough. I don't need it on my graph. This graph can be as messy as you want. I just need to know when is it above 0. So that would be here and here. And then you're just going to tell me your answer. Right, so then therefore it's going to be, it says solve. It doesn't say which notation. I'm just going to do, actually I'll do both. Right, I'll do both just so we can see both. So interval. I'll just keep doing both. But please don't do both on an evaluation. Like, just do one. Just do interval if it's not asked for, and then set. Okay, so this would be x is element of, and it's going to be between -4 and 1. How do I know if it's equal or not? Yep. There you go. Go back to the sign. Not equal. Not equal. Go back to the original. Not equal, right? So that's going to be open, right? So here, not equal, right? So just look at the sign from the beginning. So then it's not equal, and we're going to go, it's going to go from -4 to 1, or, and it'll go from 3/2 to infinity. That's it. In set notation, it would be from -4 to 1. And again, you can use or the word or. It'll be x is greater than 3/2. Okay. So don't turn the page yet. I want to look at this with that thing called a number line. Again, you can graph it like this. You can answer like this the whole chapter. It's fine. I'm never going to make you do the number line. Just know that there are other options to solve it. So I'm going to show you what the number line looks like. The number line matches this. So we're going to just put it to the side. I hope you left a little bit of room here. So the number line says from this factored form. So you take it from this factored form, and you would say, without knowing what the graph was. So the number line is a method where if I didn't know what the graph was, like if I get much more complicated functions, then I don't know what the graph looks like. So I'm actually using this to graph it, right, to kind of guess what the graph is. So if I didn't know what it looked like, I would say I still know where my roots are. My roots are still -4, 1, and 3/5. Doesn't matter about the spacing, okay? Then what I would do is I would test a point. So I'm just going to put a line because this is not part of my answer. I'm just showing you the other method. Okay. And I would test a value. I would say, you know what? I wonder what's happening to my graph. Sorry. I wonder what's happening. Yes. Oh, sorry, 3/2. That's me. Sorry. Ugh. Copying down wrong. Thank you, thank you. Okay, this is me wondering what's happening if I could imagine the graph. So without knowing what the graph looks like, a number line pretends to figure out where the graph is. Yes? Oh, no, I'm not even looking. I'm going to do tick marks. So it's not where the dot is. Yeah, sorry, I'm not graphing it. It's just tick marks. Thank you. Okay, so just tick marks, not points. Just tick, 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 where the roots are. And what I'm doing is I'm testing to see. So I want to test a value to the left of -4. So say test x equals -5. Okay? Where am I testing the value? In the factors. The factors are these: x minus 1, 2x minus 3, and x plus 4. I'm going to test it into the first factor. -5 minus 1 gets me -6. I don't care about the number. I just care about the sign. It's a negative number, yes? Okay, don't put the 6, just negative. Test the value -5. And again, this part is in your head, and you just write your test score here. And then the factor table, you write out the factors on the left side of the table or the right side, and then you fill in each box. And then I'm lazy. Sorry, I am. I just write them down here. And so instead of doing a whole chart, I'll show you the chart later if we ever use it, but we're not going to because most of you graph it. Most of you go, you know what, that's way faster. I'll do that. Interesting to know, but you do this. But I'm just giving this an option. So I would test the -5 in the second factor. 2 times -5, -10, -3, negative number. I know it's -13. I don't care about the value, just the sign. Times the last one, -5 plus 4, -1, I just care about the sign. 3 negatives times each other gets me a negative. So for sure it's a negative number. I don't know what the number is, but I know that the graph would be somewhere down here. Does that match? Yeah, the graph would be somewhere below the x-axis. Okay, then you test the same 1, 2, 3 factors, and then you're going to test, what should I test here? Shall I test?
Can you just like alternate?
It's not going to always alternate.
But like, can you see it's order 1 and then alternate?
Yes, so because you know that, but what I'm going to do, so because they're order 1, they're going to alternate. What I do later is I put it over and I put something on the bottom, say square it. I got a power of 1/2. So see how these all are nice? This method, this is what I'm saying. This method is not useful because we know what the graph looks like. It's hard to go, wait, but I know what the graph looks like. Why would I do it? This method is actually good for the graphs we don't know. If I put a power of 1/2 here, or 7/3, you're going to go, I don't know, what's happening? What do you mean, right? And then I have roots and other roots. I have over, I have negatives. You have no idea what the graph is looking like. So this method works for anything, even if I don't know what the graph looks like. That's why I said, if you know this is 2 seconds. You graph it, boom, 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 I'm done. This is going to take you longer because you're testing each value. This method works if you don't know what the graph looks like. If you know what the graph looks like, this is way better. That's why I said all my students end up doing this. I'm showing you this as an option, but it's not the best option. Yeah.
Throughout this unit or this course, we're going to have any questions?
Nope, not for chapter 4. I said, right. So chapter 4, it's only polynomials, not in this not in this course. Yeah. Okay. So chapter 4 is only going to do this, so you can always do this. I'm showing you one more time as an option and as a possibility. If you cannot factor, if you cannot graph, right? If you got all the graphing questions wrong in chapter 3, you might have to go to this. But you got to be able to do it faster. Like you can't be sitting here going, it takes me 15 minutes. It shouldn't take you 15 minutes. And then later on when we get to calculus, I'm not giving you 15 minutes for a table like this. Right? You should be able to do 1, 2, 3, negative, negative, positive, like fast. So let's try it again. So again, just as an option, if you're like, I can't graph it, absolutely can't, then this is an option. Okay? Test what value is good to test between -4 and 1. How about -2.73? I'm just kidding. 0. Yes, so 0. Right? So definitely choose something easy. Don't go fancy. 0. 0 minus 1 is negative. 2 times 0 minus 3 is negative. So bit of mental math fast. 0 plus 4, positive. So that's how fast you should be doing it. Right? So if you want this as an option and you're like, okay, I can't graph it, I get them wrong every time, then you do have to do the number line. Right? So here, negative, negative, positive. So this is positive, so we know it's above the graph somewhere here. Don't know where it is, but it's above. It should alternate. Will it always? Yes, in this case, because it's easy, but no, it will not always alternate. If I square something, right, cube something, then it won't alternate. So then here, test another one. So here I would test, and again, you don't have to tell me what you test. This is your brain. X equals, if it's 1 and 1.5, I'm just going to test 1.1. Right? And you can do decimals. This is your brain. I don't know what's happening in your brain. Right? 1.1 minus 1, positive. 2 times 1.1 is 2.2. Minus 3, negative. 1.1 plus 4, positive, so I know it's a negative. So I know it's below again. So it goes negative, positive, negative. And then, yes, it will alternate. But again, will it always alternate? No, because I can square things and everything. But in this case, it does alternate. So test, a nice value is 1.5, say 3, 2, right? Whatever you want. 3 minus 1, positive. 2 times 3, 6 minus, positive, positive, so positive. So then where is it negative? Where is this going to be above, sorry? Where is it positive? It's going to be positive here and here. And is that the same answer I got here? Yes. Right? So that interval and that interval. Right? So if you're like, I cannot graph, I graph it always upside down, I graph it backwards, something, then you've got to do the number line. So that's why there are 2 options. This one, yes, it can take longer, but you're supposed to have it in factored form and do it fairly quickly, the factors. Negative, negative, positive, 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 negative, right? So it should be fairly quick. And then you have to practice that in a timely way if you want to do that as an alternative to that. Okay? I won't tell you one way versus the other, so it's up to you. Okay? And yeah, I don't think in this course we do anything beyond it. I think it's calculus. Okay, any other questions? Okay, that's it.